February 1933, Boeing Field, Seattle. A test pilot named Leslie Tower straps into a brand new aircraft, guns the throttle, and lifts off the runway. 40 minutes later, he lands, and in those 40 minutes, every single commercial airliner flying in the United States has just become obsolete. Not slightly outdated, not due for a refresh, obsolete, overnight. The plane Tower just flew was 50 miles an hour faster than anything in scheduled airline service. It could climb to 11,000 feet on one engine, fully loaded with passengers. It had retractable landing gear, an all-metal skin, an autopilot, and de-icing equipment. Features that sounded like science fiction to anyone flying in 1933. This is the story of the Boeing 247. It's the story of how one aircraft wiped out an entire generation of aircraft in a single morning, and how, in doing exactly that, it planted the seed of its own destruction. Because the plane that ended the Ford Trimotor also, indirectly, built the DC-3, the aircraft that would go on to dominate the skies for the next decade. Stick around, because the way this plays out is one of the great "be careful what you build" stories in industrial history. To understand how big a shock the 247 was, you need to understand what airline travel actually felt like before it. The workhorse of American aviation in the early 1930s was the Ford Trimotor. 3 engines, corrugated metal skin, fixed landing gear. TWA pilot Daniel Tomlinson, who flew them regularly, described the experience in blunt terms. The fuselage shook constantly, the noise never stopped, and the whole flight was less an experience than passengers simply had to survive. There was an alternative, the Fokker F-10, a quieter aircraft with a wooden wing structure. Quieter, but not necessarily safer. In 1931, a Fokker F-10 carrying Notre Dame's legendary football coach Knute Rockne broke apart mid-flight after moisture had silently rotted the wooden wing spar. Rockne died in the crash, and the accident became a national story, and a turning point. It pushed the entire industry towards all-metal construction, and it planted a seed of public distrust in the aircraft flying America's mail and passengers. So going into the early 1930s, the state of the art was loud, slow, occasionally structurally suspect, and cruising at around 115 miles an hour if the wind cooperated. Boeing, at this point, wasn't even really a passenger airline company. Its real expertise was in military aircraft, specifically the B-9 bomber and the monomail mailplane, both built with all-metal cantilever wing construction that was a full technological generation ahead of anything flying passengers. Boeing's president, Philip Johnson, and his vice president, Claire Egved, looked at that military technology and made a decision. Instead of slowly improving the existing airliner formula, they'd just port the bomber's engineering straight into a 10-passenger transport. That decision produced the 247. Let's get specific, because the numbers explain the shock. The Boeing 247 was 51 feet long with a 74-foot wingspan. It carried 10 passengers and a crew of 3, pilot, co-pilot, and flight attendant. 2 Pratt & Whitney Wasp engines, 550 horsepower each, pushed it to a cruising speed of around 170 miles an hour. It could climb to a service ceiling of over 25,000 feet. But specs on paper don't explain why passengers and pilots alike were stunned. What mattered was what those numbers translated to in the cabin. The fuselage was insulated and temperature-controlled, quiet enough that you could actually hold a conversation mid-flight. The retractable landing gear alone was the difference between cruising at 115 and cruising at 170, because it eliminated the drag of 2 exposed wheels hanging in the airstream. The autopilot, one of the first ever installed in a commercial aircraft, let the crew hold a precise altitude and heading for hours without touching the controls. And the de-icing equipment meant flights that would have been grounded by weather could now keep to schedule. Pilots who transitioned from Trimotors to the 247 described it again and again in the same terms. It flew clean, it responded the way you expected it to, and it simply didn't fight you. 3 months after that first test flight, Boeing Air Transport put the 247 into scheduled service between San Francisco and New York. The crossing took 19.5 hours, 8 hours faster than any Trimotor could manage. That summer, on that same transcontinental route, Ford Trimotor pilots could look out their cockpit windows and literally watch a Boeing 247 fly past them. The industry understood immediately what had just happened. The aircraft sitting at the gates, the Ford Trimotor, the Fokker F-10, the Curtiss Condor, hadn't gradually aged out of usefulness. They'd been eliminated in a single morning. Here's the part of the story that people usually skip, because the 247 wasn't actually perfect and the imperfections mattered enormously. The wing spar, the structural beam carrying the load of the wing through the fuselage, ran directly across the cabin floor at waist height. Every single passenger boarding the plane had to physically step over it to get to their seat. In an aircraft that was supposed to feel like the future, this was a small, constant physical reminder that the engineering hadn't been fully worked out. Boeing's chief engineer, R.J. Minshall, had actually pushed for a larger aircraft. He lost that argument. The final call was for the 10-passenger layout built around the existing Wasp engine, partly because of pilot preference and partly because of hangar size limitations at smaller regional airports. That decision, small aircraft, 10 passengers, the wing spar left running through the cabin, would matter enormously within 18 months, because Boeing was about to hand its competitors a blueprint for exactly what to fix. But before we get to that, there's an even bigger unforced error. And this one wasn't an engineering choice. It was a business decision. Boeing didn't own just an aircraft. Boeing owned an airline. Boeing Air Transport operated inside United Aircraft and Transport Corporation.
the same holding company that also owned United Airlines. And Boeing made a call that in hindsight is almost unbelievable. It reserved the first 62 47s exclusively for United. No other airline in America could place an order until United had taken full delivery. Reportedly, William Boeing himself suggested selling to competing airlines during production. He was overruled. Company president Philip Johnson held the line. United gets 60 modern aircraft before anyone else gets one. For United, this was a brilliant, obvious strategy, a multi-year head start over every competitor on the most valuable routes in the country. For every other airline in America, it was an emergency. Jack Frye was vice president of operations at Transcontinental and Western Air, TWA, and TWA flew the exact same transcontinental routes as United. Frye understood the math instantly. His planes were older, slower, and now, as of that February morning, visibly, publicly obsolete. And he couldn't simply buy his way out of the problem because Boeing had sold every available 247 to his direct competitor. So on August 2, 1932, months before the 247 had even entered commercial service, Frye did the only thing he could do. He wrote a letter. He sent it to several aircraft manufacturers, laying out exactly what he needed. An all-metal monoplane, maximal weight of 14,200 pounds, capable of flying over 1,000 miles at 145 miles an hour with room for 12 passengers and a crew of 4. And critically, it had to be able to maintain controlled flight on a single engine from any airport on TWA's network, including Albuquerque, the highest elevation stop on the transcontinental route. One copy of that letter landed on the desk of a 40-year-old aircraft builder named Donald Douglas. Douglas Aircraft had never built a commercial passenger transport. Its business was military aircraft and mail planes, but Douglas convened his senior engineers, including his chief engineer Arthur Raymond, and decided to answer Frye's letter. Here's where Douglas' team made the decision that changed the outcome of the whole story. Frye's letter had asked for a trimotor, 3 engines matching the language of the era. Raymond's engineers didn't feel bound by that. They ran the numbers and concluded that 2 sufficiently powerful engines could meet every performance target in the letter, and a 2-engine airframe would be lighter, cleaner, and faster than anything carrying a third motor. So the proposal Douglas sent back wasn't what Frye had technically asked for. It was better. 14 passengers instead of 12, 2 engines instead of 3, a top speed pushing 180 miles an hour. Frye said yes. TWA brought in its technical consultant to evaluate the design, a man who by this point was already the most famous aviator alive, Charles Lindbergh. And Lindbergh had one non-negotiable demand. The aircraft had to prove it could climb on a single engine from Albuquerque's altitude. That single requirement became the engineering bar Raymond's team had to clear. The result was the DC-3. It flew for the first time on July 1, 1933, just 5 months after the Boeing 247 entered airline service. Testing proved it met every one of Frye's specifications, including Lindbergh's single-engine climb demand. Only one DC-1 was ever built. It was a proof of concept. But the design was refined almost immediately into a production aircraft, and that aircraft was the DC-2. The DC-2 entered service with TWA in May of 1934, 15 months after the 247's debut. And it didn't just match Boeing's aircraft, it answered point for point every compromise Boeing had made. 10 passengers on the 247, the DC-2 carried 14. A wing spar running across the cabin floor forced passengers to step over it. The DC-2's engineers integrated the wing carry-through structure into the fuselage itself, so the cabin floor stayed flat and clear. A cruising speed of 170 miles an hour, the DC-2 cruised at 190, and could cross the continental United States in 13 hours, 6 hours faster than the 247. And there was one other difference, arguably the most important one of all. Douglas wasn't locked inside a corporate structure that forced it to sell to a single airline. Douglas sold to whoever showed up with a purchase order. Every carrier that had been frozen out of the 247, which was every carrier except United, could now buy the aircraft that beat it. By October of 1934, the gap between these two aircrafts was on full public display. The McRobertson race ran 11,300 miles, from Milton Hill, England, to Melbourne, Australia. Roscoe Turner and Clyde Pangborn flew the improved 247D, faster propellers, a redesigned windshield, top cruise speed of 189 miles an hour. They finished third in just under 93 hours. Second place went to a Douglas DC-2, not a stripped-down racing version, a standard KLM airliner in its ordinary passenger configuration, carrying mail and 3 paying passengers on what was essentially a scheduled commercial run. It finished in just over 90 hours, beating Boeing's best racing effort, while flying an actual airline route. Boeing had built the fastest airline in the world. 18 months later, it had been beaten in an intercontinental air race by a competitor's regular passenger flight. Boeing ultimately built 75 247s in total. 60 went to United, as promised. The remaining 15 went to other buyers, including Lufthansa and Customer in China. The production line remarkably closed in 1933, the same year it had opened. United kept flying the 247 on its main routes for a few years, then gradually shifted the fleet down to smaller regional runs as newer aircraft arrived. Some were converted to military transport and training roles during the Second World War. A small handful survived in corporate and utility use all the way into the 1960s. There's also a darker footnote to the 247 story. On October 10, 1933, just 6 months after entering service, a 247 operating as United Airlines Trip 23 exploded in midair near Chesterton, Indiana, on a flight from Cleveland to Chicago. All 7 people aboard were killed. Investigators traced the cause to a nitroglycerin-based device planted in the cargo hold. It remains the first confirmed case of commercial airline sabotage in aviation history. No suspect was ever identified. Here's the chain of cause and effect, laid out end to end, because this is really the whole point of the story. Boeing builds a revolutionary aircraft. Boeing refuses to sell that aircraft to any airline except its own. That refusal forces TWA's Jack Frye to go looking elsewhere. Frye's letter lands with Douglas. Douglas's engineers, unbound by the specifics of that letter, build something better than what was even asked for. First the DC-1, then the production DC-2. And the DC-2 was good enough that it caught the attention of American Airlines. CEO C.R. Smith watched the DC-2 in operation, and he wanted something even bigger. an aircraft large enough to carry sleeping berths for overnight transcontinental flights. In 1935, he went back to Douglas and pushed hard for a larger design. Douglas, still deep in DC-2 production, wasn't eager to start over. Smith pressed the case anyway. The contract was signed. That aircraft first flew on December 17, 1935. It carried 21 passengers. It could cross the country non-stop. And crucially, it could turn a profit carrying passengers alone, without needing a government mail contract to stay in the black. It was called the DC-3. By the time the United States entered the Second World War, 80% of all commercial airlines flight in America were variants of the DC-3. None of that happens without the 247. Every decision Boeing made to keep costs and complexity down, the 10-passenger cabin, the wing spar across the floor, the smaller Wasp engine chosen because a bigger aircraft seemed impractical for regional airports, became, without Boeing intending it, a checklist of exactly what Douglas needed to beat. And every one of Boeing's business decisions, most of all the decision to keep the 247 for United alone, handed its competitors the motive to do it. The Boeing 247 ended the trimotor era the morning it first flew, and the era it opened lasted, in real terms, about as long as it takes to build the next aircraft. The DC-3 arrived and closed the book on the 247 within a single president.